Dear friends, we are coming into the next operation of merging two ordered lists into a single list, which is the inverse of, let's say, splitting. So here we have two lists, P and Q. The items are ordered, let's say P with n items, Q with m items, and we need to create a resultant list called R, which will have the items of P and Q in an ordered fashion. So this is what we get. So let's see how we can do this. The basic algorithm, of course, which can be converted directly into a program, is here. So this is the first order, the first part, this is the second part, and this is the third part. Since we are limited with the slide, we had to somehow push it in together, but I think it will be clear to you as we go ahead. Let's just go through the explanation how we can look at this. So we have created P and Q using the create algorithm, two linked lists, and the items are ordered. Now the resultant list is going to be R, which will be again ordered items. So in order to mark the beginning, I keep a pointer called start and I initialize it to null. This is to take care of, as we had said in the previous program, you will have the possibility of first time and the remaining. So I use the start, I make it as a null. So how do I do this operation? Let's look at this. So while both lists not over, of course this is a simple logic which can be converted as while P not over, Q not over, that is while P not equal to null and Q not equal to null, I'm going to do an operation of a compare, which is P's data with Q's data. P data is smaller, 1 is smaller than, so which means this part of the program will take place, that is from here to here. So here again there are two possibilities, first time or remaining. So now it is the first time, so this is going to take place. If it is the first time, how do I know first time? By saying start equal to null. Start is null, so now I'm going to create my first node. A node R is created, and I'm going to mark that as start and previous. It's the first time, so I keep a pointer called start here, and also it is R, there's a node that I created, and I'm going to keep a previous pointer because this is what I will use for connecting next consecutive nodes. So 3 nodes are kept here, so comes here, it's over. Then I copy P's data to R data. P's data is this, that is 1 is copied to R data, so 1 comes here, and R of next equal to null, this is made null. Then P advances, P goes, now P is advanced because I've copied from here, so P comes to this node, and Q is still remaining here because Q has not advanced, so this part is over. Now we go back in the loop. I'll come back here again, both lists not over, 5P data. Now we are going to compare again, so just to tell you the point, we are here and P is here and Q is here. Now we are going to compare again now these two nodes, and we realize Q's data is less, which means this will come to the portion here. That means this is the portion that is going to run. It is less than, so it is not first time, so it is going to, this is the part that will be taken, second part, because it is not the first node. So Q's data, so I'm going to create an R, so this is the R created now, and previous next equal to R, previous next equal to R, so this is my previous next equal to R, this gets linked, previous next equal to R, and my previous now moves from here to this node R and copy the data from Q data to R data. That means Q data 2 gets copied here, the data is copied, and R next equal to null, this becomes null because last node now, and Q advances. So Q now advances and Q now reaches outside, which means it is outside the list. So in a way one list is over, Q is over. Okay, So these are two possibilities. One list can be over, the other list not over, or it is same as saying one list is a null list, no items, and the other list has got number of items. So here we have a case where the list Q is over and P is not over, or P items are there. So this is a condition. P is not over, or other way, Q is over. No? So I'm going to look at this portion. The reverse, the order of the algorithm is 1, 2, 3. We can put it either way and look at this. So let's look at this. Q, if Q equal to null, so this Q equal to null means this item is over, that is true. So I'm just going to copy from here. So while P not over, it's clear. While P not over, it is not the first time now because it's the second time, so it will come here. R node, so I'm going to make a new node. This is a new node. R equal to get node. Previous next equal to R, the linking takes place, and previous equal to R. From here the previous will move now here, and copy P's data to R data. P is here, 3 will be copied here, copy data, and R next equal to null. This is made null, and P advances. P now moves from here to here because only P needs to be advanced, so it will go back again, and again only one node, so comes again back here. It's not the first time. P is not over, comes here. R equal to get node, R is made, and previous next, this link is taking place, and previous equal to R. This is going to be the link will move, though it is going to be the last node, and previous equal to R, and copy data from P's data to R data. So 5 will get copied here, from this 5 gets copied here. R next equal to null, this is made null, meaningful. Now P becomes P next. Now P is outside. P becomes P next, and P is now equal to null, so P is over, this portion is over, so algorithm comes out. This was the last part. Return start. So what I will finally return is the start of the program, that is this, my resultant list. So all other is over. So reversely, if P was over, Q not over, then I would have executed this part. So if you put together 1, 2, 3, we will have a resultant program that combines two ordered lists and have a resultant list which is also ordered. Make sure you do not manipulate the pointers like in some books. What they do is they combine these two together. That should not be done. That is not proper process of doing it. It is better that you combine them like this and get this organized. I think it's clear, and we are able to make this program, this algorithm, into complete program, and maybe make yourself better clearer by implementing it. So just to confirm again, finally this becomes the start of the program. That is what I am returning finally. Thank you.